Okay, now it's time to look at topic 6-12, integration using partial fractions. Okay, so basically what we're going to do is we're going to use partial fractions to rewrite rational functions into separate parts that we can then integrate into separate terms or into separate fractions. Now you might have some experience using partial fractions in other math classes. If not, that's totally okay. Let's just go ahead and start with an example and we'll go from there. This is a pretty easy example. Let's say we have the integral of 1 over x squared plus 5x plus 6 dx. Okay, so up to this point in calculus, you've seen integrals of polynomials. So polynomials, whenever you have x to different powers with different terms. And you've seen polynomials actually in the numerator and in the denominator. And in some cases, we can use u substitution to cancel out polynomials in the numerator and denominator. If one polynomial is one higher than the other and you can factor it, and the factors cancel out, or use u substitution if you can take the derivative of part of it and then it cancels out with the other part. But what we're going to see are examples where u substitution won't work. And unless you get really, really experienced at these, you might try u substitution or factoring or other things at first before you realize, oh yeah, I can't do that. And so partial fractions will help us to rewrite these polynomials in a way that we can actually do something with it. And most of the time we're going to have the bigger power on the bottom, although the higher degree on the bottom, although we will see an example that's different. So all right, so let's just jump right into this. So basically, you do have to be able to factor your denominator. So all of these will work, that they're either already factored for us or something you can factor yourself. So let's change this to x plus 2 and x plus 3. Okay, so we're going to kind of leave the integral alone for a second and work on the idea of partial fractions. Partial fractions is a way of splitting up denominator factors into separate fractions. And it's a process that goes like this. So we will rewrite the left side equal to some missing number over the first factor plus another missing number over the second factor. And of course, if you had a third factor, you'd have plus c over that. If you had a fourth factor, you'd have plus d over that. So this time I'll kind of work it out slowly, but on the next problems I'll do this next step a little quicker. But basically we want to multiply both sides by that denominator on the left side. So we're going to multiply both sides by x plus 2 times x plus 3. And so on the left side it all cancels out and we're back to just the normal 1. On the right side, for the a term, we had an x plus 2 on the bottom, so it cancels out with the x plus 2 on top, and we just have x plus 3. And then likewise for the b term, we had an x plus 3 on the bottom, which cancels out, so we have x plus 2. Okay, so we have rewritten it into a way that we can actually solve for what a and b are. We're trying to find the a and the b to turn that original integral into an integral with partial fractions. So let's solve a first. And so I want to eliminate the b term. So we're just going to kind of temporarily say, let's let x equal negative 2. And so whenever we do that, that will give us a times negative 2 plus 3, and then b times 0, which makes the b term go away. That gives us an a of 1. Then kind of we'll similarly do that to find the b term. So we'll say, okay, well let's let x be negative 3 this time, because that will cancel out the a term. So we have 1 equals a times 0 plus b times negative 3 plus 2, which is 1 equals negative b, so that gives me a b of negative 1. So what I'm able to do now is I'm able to take that original polynomial on the denominator and rewrite it now as a new a, 1 over x plus 2, and then a new b, negative 1, so minus 1 over x plus 3. All right, so I put my a in there, and I put my b in those spots. Okay, so what's the whole point of all of this? Well, now we have, instead of our original integral of 1 over x squared plus 5x plus 6, we can now rewrite that as the integral of 1 over x plus 2 dx minus the integral of 1 over x plus 3 dx. And these are actually integrals that we can work with. A lot of times these integrals end up having ln as part of the answer, and in this case both of these terms do. So the integral of 1 over x plus 2 is the natural log of the absolute value of x plus 2, minus the integral of the next one is the natural log of the absolute value of x plus 3, and then we have c, and that is the answer. So that's the only way that we could do that. We started with a polynomial in the denominator that we had no other way to work with integration tools that we know. And so we were able to work it all the way out by changing that polynomial into separate terms using partial fractions. Now that's the gist of the lesson. That was a really pretty easy, straightforward example. I do have two more examples to go over with you, and they both get more complicated as we go. I will go a little quicker now on some of the basic steps, so if you need to pause the video to understand things, then do that. So let's do the integral of 2x squared plus 7x minus 1 over x cubed minus 4x dx. Okay, so again we have a rational function. We have on top we have a polynomial, on bottom we have a polynomial. We have no other tools to be able to deal with this. However, the only time we can use partial fractions is if the bottom is written as factors. So let's factor out that bottom. We'll pull the x out to the front. We have x squared minus 4, which is a perfect square difference of squares. So that will be, x plus 2 and x minus 2 dx. Okay. So here we go. We're going to go ahead and leave the integral alone for a minute, and we're going to find the partial fractions. So we take our integral, the thing that we're taking the integral of, that whole expression, and since we have three terms in the denominator, we're going to say a over x plus b over x plus 2 plus c over x minus 2. Okay, we're going to cross multiply like we did before, and that leaves 2x squared plus 7x minus 1 on the left. And on a, it has the x term, it does not have the x plus 2 or x minus 2 term, so we'll multiply that with a, which is x squared minus 4, getting with the a. The b has the x plus 2 term, so it does not have the x or the x minus 2 term, so that would be x squared minus 2x goes with b. And the c does not have the x or the x plus 2 term, so that's going to be c times x squared plus 2x. Okay, so let's go ahead and start working these out. Basically, you're just trying to get each individual letter's term by itself. So I can start by saying let x equal 0, because that will eliminate my b and c terms. So we'll have 2 times 0 squared plus 7 times 0 minus 1. A gives me 0 squared minus 4, and b goes away, and c goes away. So all of that becomes negative 1 equals a times negative 4, and that gives me an a of 1/4. All right, so now we're going to keep doing this with our other terms. Let's go ahead and let's let x equal, well, let's see, if we let it equal to 2, that'll cancel out the a, and if we let it equal to 2, that'll cancel out the b. So now we're going to be solving for c. So here we go, 2 times 2 squared plus 7 times 2 minus 1, and the a goes to 0, right? 2 squared minus 4 is 4 minus 4. The b goes to 0, 4 minus 4 again, and then my c, I'm running out of room, is going to be 2 squared plus 2 times 2, so 4 plus 4 is 8. So on the left side, we have 2 times 2 squared. We have 8 plus 14. And then, whoops, I did lose my minus 1, or it kind of got in there. I'm going to erase that plus sign there. I'm going to put minus 1 there. All right, so if you're missing that, if you were copying down, I had a random plus sign there. I changed it to minus 1. I think everything ran together. I don't remember what happened. So we have 8 plus 15 minus 1 is 21 equals C8. And that means C is 21/8. And finally, we need to find what the B is. So now we're going to cancel out the A and the C. So we're going to let X equal -2. So 2 times -2 squared plus 7 times -2 minus 1. And that's going to cancel out the A. It will not cancel out the B. -2 squared is 4. Minus 2 times -2 is a plus 4, so that's B8, and the C is 0. So we end up with 8 minus 14 and minus 1, so -7/8 equals, I'm sorry, not -7/8, that'll be in the second, equals B times 8, and then we'll divide B on both sides, or 8 on both sides, and get -7/8. Okay, a lot of work. What have we done? We have taken our original rational function, and we can now put A over X, so 1/4 over X, plus B over X plus 2, so that's -7/8 over X plus 2, plus C 21/8 over X minus 2. All right, and we're taking the integral of all of that. And so we can integrate each term separately. And so it's simply going to be this. 1/4 the natural log of the absolute value of X minus 7/8 the natural log of the absolute value of X plus 2 plus 21/8 the natural log of the absolute value of X minus 2 plus C. And there you have it. That is our answer. A lot of work on these problems. You really got to persevere through all of the steps. All right. We have one more that we're going to look at, and this one's going to be just a little less fun, but it is a method that we need to see and we need to be able to do. So here we go. Last one. Let's do the integral of x to the third plus 3x squared minus 4x plus 5 all over x squared plus 2x minus 3 dx. Okay, so the first thing that you should recognize, let's say you're taking an AP exam and all of a sudden this problem shows up and it doesn't give you instructions about how to integrate it. And so the first thing you should recognize as you kind of go through your steps of how to solve a problem like this or any integral is you should see that the numerator's degree is higher than or greater than the denominator's degree. And whenever our numerator's degree is greater or equal than the denominator, our best bet is to go ahead and use long division to rewrite the integral into something more useful. So that's not this lesson, right? That's something that is a previous calculus topic, but it mixes into this problem that we're going to end up using partial fractions with. So let's go ahead and let's use some long division to rewrite this integral into some separate terms that we can work with just a little bit easier. So here we go. And let's see here. So x squared goes into x cubed an x time. We're going to multiply that back through. And then we're going to subtract all of that out. The x cubes cancel out. We get a single x squared. And we get a minus x. And we'll read down the plus 5. All right, now x squared goes into x squared one time. We're going to multiply all that out. Going to subtract all of that. The x squareds go away. Negative 3x plus 8. That is my remainder. So minus, well, let's just do plus negative 3x plus 8 all over x squared plus 2x minus 3. Okay, so we can rewrite this integral now as the integral of x dx plus the integral of 1 dx plus the integral of, well, let's see, we have negative 3x plus 8 over x squared plus 2x minus 3 dx. Okay, now as we think about how to approach these three integrals, we see the first one's an easy one. That's just the power rule of integration. So that's going to be x squared over 2. That's done fine. The next one's easy. The integral of a constant is just that constant times x. So that's going to be 1x. Done. The third term, the third integral, though, this is an example of a rational function. And so we have, we're going to have to use integration by partial fractions in order to clean this out. So I'm not going to touch those first integrals until maybe we're ready to evaluate the last integral. So let's go ahead and use, kind of leave the integral for a minute and do our partial fractions steps like this. And I guess I should just go ahead and rewrite that bottom into its factors. So let's see, that would be x plus 3 and x minus 1. Okay, so here we go. We're going to put the a over x plus 3 and a b over x minus 1. And then we're going to cross multiply. Negative 3x plus 8 equals a times x minus 1 plus b times x plus 3. All right, so let's get rid of the b. So we're going to let x equal negative 3. So that's going to be 9 plus 8, 17, equals a times negative 4. And then a will be negative 17 fourths. And then we can do the same thing, same idea to eliminate the a. We're going to let x equal positive 1. So negative 3 plus 8 is 5. And that'll give me a 4 times a b. And b is 5 fourths. All right, so back to our original problem. We had that original integral, the two original integrals. And then we had this new integral that we can now call, the a is negative 17 fourths over x plus 3. And then the b, and dx there, the b is 5 fourths over x minus 1 dx. Okay, so now let's do our integrations, and we're going to get ready for an answer. So here we go. The integral of x dx, the very first one is x squared over 2. The integral of 1 dx is simply x. The integral of negative 17 fourths over x plus 3 is minus 17 fourths times the natural log of the absolute value of x plus 3. And the next one is plus 5 fourths times the natural log of x minus 1. And that is all plus c. And that is the final answer.